Question 6. This question is of trigonometry. Express 3 cos x plus 2 cos x minus 60 degree, 3 cos x plus 2 cos within bracket x minus 60 degree in the form r cos x minus alpha. R cos x minus alpha, where r is greater than 0 or r is positive, and alpha lies between 0 and 90. State the exact value of r and give alpha correct to two decimal places. We have to find the value of r and alpha. Actually, we have to express this expression in this format. So first of all, we are using here the important for identities of trigonometry. 3 cos x plus 2 cos x minus 60 degree. We are using here the identity cos x minus 60. Expansion of this will be by using important formula, yeah, identity. We are expanding this 3 cos x plus 2. Now we are expanding this. We get cos x cos 60 degree plus sin x sin 60 degree. Now we will put the value of cos 60 degree and sin 60 degree. We get this 3 cos x plus 2 into value of cos 60 degree is 1 over 2. So we can write 1 over 2 cos x plus value of sin 60 degree is under root 3 over 2 sin x. Value of sin 60 is under root 3 over 2, sin x remains the same. So now we will multiply this by the two terms of within bracket. So this becomes 3 cos x plus cancel out. In the first term, we can write cos x plus, from here 2 is cancelled, we get under root 3 sin x. Collecting or adding these two terms, we get cos 4 cos uh, 4 cos x plus under root 3 sin x. First, we have written this expression in this form. Now it is given that we have to express in this format. So we are equating the this expression with the given format, that is r cos x minus alpha is equal to r cos x minus alpha. Now again we use here identity to expand this cos x minus alpha. Left hand side remains the same. 4 4 cos x plus under root 3 sin x is equal to, and we are expanding this, r within bracket cos x cos alpha plus sin x sin alpha. Multiplying r by these two terms, we get r cos x cos alpha plus r sin x sin alpha. Left hand side remains the same. 4 cos x plus under root 3 sin x. Now, next there are three steps. First is first step is mm, we have we are equating this. First step is to compare the coefficients of uh, cos x and sin x. This is the first step. Comparing comparing coefficients of cos x and sin x. This is the first step. Clearly, the coefficient of cos x on the left hand side is 4. On the right hand side, the coefficient of cos x is r cos alpha. So we can write 4 is equal to r cos alpha. Let this is equation number 1, and under root 3 is equal to comparing the coefficient of sin x, and on the left hand side under root 3, on the right hand side r sin alpha. Let this is equation number 2. Now actually we have to find the value of alpha and r. Now we will solve these two equations simultaneously. To solve this, we are scaling and adding. This is the second step. Scaling and adding these two equations, equation 1 and 2. Scaling of equation number 1, we get 16 is equal to r square cos square alpha, and scaling of equation number 2 we get 3 is equal to r square sin square alpha. Now we are adding these two equations. We get 16 plus 3, that is 19. Right side r square is common. We can write sin square alpha plus cos square alpha, because r square is lying in both the terms. We can take common. Now sin square alpha plus cos square alpha, this is very important identity. This is equal to 1, we know already. So we have two values of r. Taking square root, we get r is equal to plus minus 19 under root, but it is given in the question statement that r is positive, so we are taking the positive value of r, that is 19 under root. So next, no, third step. First step is comparing, second scaling adding, or third step, now we will find the value of alpha. So we are dividing these two equations. Third step will be dividing. Dividing equation number 2 divided by equation number 1. Equation number 2 divided by equation number 1, we get here r sin alpha over cos alpha is equal to under root 3 over 4. This becomes r sin alpha over r cos alpha. Cancel out, we get tan alpha is equal to under root 3 over 4. From here, alpha is equal to tan inverse under root 3 over 4. We get finally alpha is equal to, correct to two decimal places, because we have to give the answer of alpha correct to two decimal places. We get alpha is equal to 23.41 degree. This is the value of alpha, and this is 19 under root is the value of r. Next part of this question is part B. Hence, solve the equation. Equation is same with a little difference. In the above equation, that is, in this expression, the angle is x. Angle is x in this expression, but now we have to solve. But in place of x, there is 2 theta. Now we will write this in the above part. We will write first in this form, putting the value of r and alpha. This expression will become, we are putting the value of r and alpha here. This become, r is 19 under root cos x plus alpha. Alpha is 23.41 degree. Now this expression, this is part is, this expression can be written in this form, which is this. Now in the second part, hence solve the equation. Hence means we will use the above relation. Now in place of x, we are putting 2 theta. Now we will put 2 theta in place of x in this relation, because this is the other form of this expression. So we can write this expression, this equation, by replacing x by 2 theta. We can write here r cos 2 theta plus 2 theta minus alpha. Relation is this, cos 19 under root cos x minus alpha, that is 23.41 degree. We are writing here, replacing x by 2 theta. This becomes r cos 2 theta minus alpha is equal to 2.5. Now we have to solve the equation. Solve means we will find the values of the variable. Variable in the question is theta. We will find the values of theta in the given interval. Interval is 0 to 180 degree. So first of all, putting the values of r and alpha here, 19 under root cos 2 theta minus alpha, that is 23.41 degree, is equal to 2.5. Now dividing 2.5 by 19 under root by cross multiplying process, 2 theta is equal minus 23.41 degree is equal to 2.5 over 19 under root. In decimal places, the value of 2.5 over 19 under root we get 0.5735. So cos 2 theta minus 23.41 degree is equal to 0.5735. Now we will find the basic angle. 2 theta minus 23.41 degree is equal to cos inverse 0.5735. Setting the calculator mode on degree, the value of cos inverse 0.5735 will be 55 degree. 2 theta minus 23.41 degree is equal to 55 degree. Now we know that this is basic angle. There will also be another angle that we are taking help from this sketch. These are four quadrants: A, S, T, C. Choose A for all. All means sine, cos, tan. This is the first quadrant, all positive. In this quadrant, sine, cos, tan, all are positive. In the second quadrant, S means sine positive, remaining negative. In the third quadrant, tan positive and remaining negative. In the fourth quadrant, cos positive and remaining negative. Now, in the question, clearly the value of cos of the angle is clearly positive. So, there are two values. The first quadrant it is positive, and fourth quadrant the value of cos theta is positive. So we are taking angles in these two quadrants. In first quadrant we have found the angle. In the fourth quadrant angle will be 360 minus 360 minus basic angle. Basic angle is 55 degree. So this left hand side left hand side left hand side will be equal to 55, and the left hand side will also be equal to this 360 minus 55. We get, now first we put left hand side is equal to 55. We get 2 theta minus 23.41 degree is equal to 55. From here theta will be equal to 55 degree plus 23.41 degree divided by 2. Finally, we get answer is, could have to one decimal places. The answer is 39.2 degree. This is the answer. The other answers will be from here. 2 theta minus 23 is also equal to 360 minus 55. So 360 degree minus 55 we get 305. So from here we get another answer, that is 2 theta minus 23.41 degree is equal to 305 degree. From here theta is equal to 305 degree plus 23.41 degree divided by 2. That is theta is equal to 164.2 degree. These are two answers. So finally, answers are 39.2 degree and 164.2 degree correct to two decimal places. These are the answers. These are the answers correct to one decimal places. Both the answers are lying in the given interval.